Hi, I'm Steve Ward, and in this session I want to talk about user interface design and human-computer interaction, specifically as it relates to HMI and SCADA type applications used for industrial automation and process control. So user interface design can also be referred to as UI and also UX for user experience, and we also have human-computer interaction or HCI. And these can be related to HMI SCADA applications, HMI being human machine interface, and SCADA being supervisory control and data acquisition. HMI and SCADA are sometimes different, but they're also very similar in terms of the way they're used and the way that graphics and systems might be represented. Now, the reason for this level of interface comes from the fact that PLCs and industrial controllers are black boxes that control the machine or plant. And the reason we call them black boxes is they don't have any capability of seeing what's going on inside unless you're a programmer or developer of that black box, in which case you may have access to the low-level programming and the data tables that are inside those boxes. But they do contain lots of data about the operation of the machine or plant. That might be in the form of IO tags or points or variables. But there's a lot of information there that says what the machine or process is doing. So, for example, how many widgets you've made, what the reasons for downtime are, how long the machine has been running, what speed the machine or process is running at, various set points, machine or process states, is it in automatic or manual? So there's a lot of important information there. And this is where operator interfaces and HMI SCADA come in, because they can provide a visualization layer for this data, and that allows operators and other users to understand what's going on inside those machines and processes, and also to control that machine or process. Now, it's easy to draw a screen which is just a list of numbers, but that's not very relevant to the user. So typically this is where the user interface design and human-computer interaction part comes in, because what you want to do is design a good user interface, and that's critical to allow understanding of the current and historical status. It provides fast notification of and response to critical issues, and ultimately you're looking at reducing the possibility of making mistakes. There may be other aspects as well. You might want to make a machine that looks good. If you're an OEM making machines, you might want a very attractive user interface, because that can help sell the machine to your users. And you might also want to attract newer, younger operators who are more familiar with iPads and iPhones and Android devices, and they're used to nice looking apps and swiping technologies and pinch and zoom and so on. So there's other aspects of UI as well that may also be relevant. But the key one is about understanding and controlling the plant, and doing that with reduction in the possibility of making mistakes. Now, user interface is one thing, of course. It's also important when we do have the data. Data is important because that can be used for decision making and continuous improvement. But we're not going to talk about data collection in this deck. This is really just concerned with the user and the interaction with the device via the UI and the HCI aspects. So the history of industrial automation is manual measurements made by using things like physical dials, by using sight glasses, potentially by opening up a vessel and seeing what was actually inside that vessel, or possibly in some cases there was no control, it was just designed in at manufacture and the machine ran according to its manufacturing capabilities, and that was all there was. Later, people started introducing text type displays, possibly with alarm printers, but very minimal information available from a text display, or maybe even the text wasn't even text, it was just a number. I remember working on a very old system for an automotive manufacturer, and we had a 4-digit display, and the 4-digit display, you had to control the display to tell it a number, and then the operator had to use a lookup code, and the number told the operator what was going on with the machine. So very simple text display. As technology improved, we had monochrome screens, which had a bit more information, but again, still fundamentally text type display. Then we started developing screens which had maybe shades of grey, which again could have slightly more information. Partly this was because we had more screen real estate, bigger screens, and also because we could start to represent graphics using simple text. In the very early days, you could represent a machine by using specific ASCII characters or maybe special character sets, and you could have very limited graphics, but it was still very limited in terms of the user interface and the representation to the operator. Over time, the graphics got better and better. That led to much more information on the screen, but the big challenge here, there was no standardization. So often a user would just see a box on the screen that changed color, and the user would be responsible for understanding what that box was and what the color change meant. So very limited affordance, as we call it now. It was up to the operator to have to make sense of what was on the machine. And it didn't help that a lot of these systems are put together by engineers with limited graphical skills. And also a lot of the times these systems are put together from even older systems, and the chances for upgrades are minimal because people want to spend as little time as possible to recreate the existing graphics, and also to some extent they want to minimize operator training of existing users who are already familiar with these old-fashioned layouts. So another aspect was a tendency for clutter. If it costs you a certain amount of time to develop a screen, and maybe your system is limited in resources as well, so maybe you're limited on the number of screens, there was a big tendency for engineers and developers to put as much information as they could on each single screen. So you might see a large P&ID from a process plant, and you would see on that P&ID, which might be an A0 piece of paper when it's developed, and that could be crammed into a single screen of relatively small size, so you'd get a lot of valves and pipes, you'd get a lot of different colors, you'd get a lot of different measurements, and that could make it very difficult for the operator as well. Again, training helps and operators can get used to this clutter, but it makes it very unattractive for new users, and the possibility of making mistakes is also quite high. So the current state of the art is more about minimal graphics. Often we start with a simple grey screen, and the idea there is we have very good item representation, so almost photorealistic images, or at least the outline of the device, and that makes it easy for the operator to understand what it is they're looking at. And then we have minimal color changes to indicate that operators need to make adjustments. So we might start off with grey, maybe a slightly different shade of grey to indicate everything is normal. Then that might change color to maybe blue for something is required to operate on but not urgent. And then you may get alarm colors like orange for attention needed, and red could be an urgent state. Even that's problematic though, because you get problems where different colors can mean different things to different people. I've been on one site where red was stopped, which is the safe state, and on the same site on a different graphic, red is an alarm state, which is a dangerous state. So in the same plant, in systems which are very near to each other, the same color could indicate different things. So lots of opportunities there for misinterpretation and confusion if you don't have good standards for the way you develop it. Now, the opposite of these minimal or grey graphics is rich graphics. So this is where we can have very comprehensive screens. Maybe now we're not doing photorealistic screens, but we're actually doing physical photographs of the machine, and then we're overlaying graphics and representations on top of that photograph. So two extremes there. You've got very simple graphics which just need the glance to understand what's going on, to a physical image representation of the actual device, but again, hopefully with enough simplicity of operation so the operator can very quickly understand what's going on. And then between that, you can get 3D and isometric representations of the machine as well. Again, the aim is to improve affordance, to allow the operator to understand what they're looking at without making mistakes, but also to give them enough operations and information to be able to operate the plant. That can also include multiple levels of display. So you might start off with a high level, and then you would drill down through various levels until you get to the level of detail that's important. So at a very high level, you might just have a whole graphic of the plant, and then there might be simple messages for each plant area, and then you click on those areas or tap on those areas, or maybe you're using pinch and zoom or swiping gestures, but you can then drill down until you get to the level of information that's appropriate for the actions you need to take. Now there are standards for user interfaces, but not many standards. There is a standard EMUA 191, which you come across sometimes, but that's rarely used. Alternatively, what we often find is end users have their own individual standards. So again, that can cause confusion because the standard that's used by one end user can be very different to a standard used by another end user. So, of course, if you're a developer, you need to conform to what the end user wants. But also, if the end user doesn't have very good standards, you might even want to help define those, either yourselves or in conjunction with the end user. So here are some guidelines and notes about practical implementation. The first thing you need to think about is information density and operator capability. This might vary and training can help, but you need to think that, what information level can the operator cope with? How many points can you have on the screen? How many different color changes there could be? How many different types of color? And that can even relate into human issues, such as how many colors can a human actually differentiate between as well. So a lot of aspects there. Object shapes can be important. Do you use icons? Icons can be useful, but they can be misconstrued. But icons can be useful to indicate particular functions like safety or warnings or alerts on each other, particularly if they are based on like standard road signs, which an operator might be expected to understand. Now, I mentioned colors. You need to be careful with colors. As I mentioned earlier, green could mean stop and safe, or it could mean green for go. So same with red, does red mean stop and emergency, or does it mean red is dangerous, or does it mean red is running? So different users can have different colors there. And then between red and green, there are a whole load of colors which may have different meanings. What does yellow mean? Does that mean a warning? Maybe you use orange for different levels. Maybe you use flashing colors, so that's another aspect. Maybe you use blue or green or other colors. So you need to think about what they are and what they might mean to the operators. Object libraries can help. Again, if you've got physical representations of your machine that look like the machine or process, for example, tanks that look like the actual physical tank, again, that can help with affordance and reduce operator mistakes. So this affordance, this is fundamental. It's all about making the machine or making the user interface look like the actual machine or process. But there is a cost there based on the time to develop. The better affordance you have, that can result in better operators and reduce mistakes. But in order to make a very good representation of what your machine or process looks like, you can take more time. But having said that, I think it's quite straightforward to use basic shapes to build up the outline and make something look similar to what the real world application is. That doesn't necessarily take too much time or money to do. We need to think about reaction speed. How fast can the operator react? Also maybe about overloading the operator as well. You don't want to give them too much information. How do we do navigation? So is that with a menu? Is it with a menu at the top of the screen, the bottom of the screen, the side of the screen? So you need to think about that. Maybe you're using swiping and gestures and so on. If you have common areas for common functions such as menu navigation, it's a good idea to use layouts and make that consistent. So for example, if you're using a menu along the bottom of the screen, make sure it's always at the bottom of the screen. And if there are things like back buttons and home buttons, they're always in the same place so that the operator doesn't have to work too hard to navigate through their navigation system. And when they're looking at the screen, they can look in the same place for common information. So for example, you might have an alarm banner at the top of the screen, navigation at the bottom, and then you might have common functions like overall status on the left or the right, but consistency is key there. Now, to avoid too much information, you can drill down. Another option is using pop-ups or faceplates for controlling common objects. So to avoid using up screen space, you might have, for example, a representation of a valve with a valve icon. Maybe you've got the basic operational state of the valve or whatever the key performance indicator is, and then the user can click on that valve or the KPI. That will cause a pop-up or a faceplate to appear, which could give the operator a lot more information that they need to actually perform control. So, for example, they might want to put it in auto manual mode, they might want local remote, there may be the set point capability, there may be alarm acknowledgement, that may even link through to trending. So depending on what the application needs, those pop-ups and faceplates, they can be a time saver because you only need to develop them once for each type of object, but they're also a great way for the operator to drill down and get more information and more context about what they're controlling. Now, if you're a developer, you often start with the machine layout or P&ID, but I often find there's far too much information in those initial designs than you want to display to the standard operator. So it's much better to start with a higher level representation with the minimal information, just for key performance indicators, and then let the operator drill down as they need to. So don't just start with what the information on the machine is or the P&ID is, but try and think about how the operator will work with that. Training of users is important. Just giving a user interface that's easily usable is one aspect, but what you think is usable as a developer, the operator might not think is usable, particularly if they're used to other systems or if there was a previous system which was different. And another possibility is think about testing and refining designs. When you're training users, you might get feedback that certain bits are hard to understand. You might perform user testing. One aspect is maybe A/B testing, where you give the user two different screens and let them choose which is the best one. Or you might look at different teams and say this team is making more mistakes than this one based on their A/B comparison. Of course, that costs more time and costs more money, but again, if your idea is to make the system more usable and reduce mistakes, then that's a good way of doing it. So a common question is, how many items should there be on a single screen? I think the answer is simple. It's maximum 10. A typical human can take in 10 items quite easily. If you want to, you could also display those in multiple formats. So again, you might have an icon which has different colors. You might also have a value printed on top of that icon, but it should all relate to the same information about that particular thing it is you're operating. So for example, consider a valve. You might have green for open, red for closed. You might say the actual process value that you're controlling, such as flow, if it's a valve, or maybe it's temperature or level or something. So you could have several different values. Maybe you also change color with an icon, maybe a flashing exclamation mark if there's some urgent attention needed, or maybe some other color code. But the idea is, overall, each screen should only have about 10 different items, even if there are multiple display formats for each item. So often plants have more than 10 items, so this is where layers might come in. Maybe you zoom in, or maybe you use some sort of click and operate there to drill down, and you have multiple layers. You don't want too many layers. Maximum is probably 3 layers from the top level down to a detail screen. There might be some room for movement here depending on how complex the application is, but again, you've got to think about what your operator is capable of operating. And again, those pop-ups and faceplates can be useful. So you might drill down into more detail with 3 layers, but then one additional layer could be pop-ups or faceplates. It's also worthwhile clustering related information. You want to avoid too much navigation, so make sure that the user can see common functions on one screen, and that can mean duplicating information. So you might have one screen which shows information for a particular aspect. You might have a different machine or a different screen, but some of that same information is also there because it's in more one place than another, and there might be some sort of natural clustering to display different aspects on different screens in different ways. For discrete items, you could use a standard icon and color code. As I mentioned, you might use green for on, red for off, yellow for alarm. Just be careful, as I said, some people have different color choices based on what they consider to be safe or unsafe. Another option might be grey for normal and red for alarm. So the important thing is not so much what the colors are, as long as you get agreement from all of the stakeholders that the colors mean the same things. For analogs, you could use the value, but you might also want colors to indicate minimum, maximum, and a good example is using a gauge with limits or percentage rather than absolute numbers, along with the absolute number as well, because again, people can look at that and have a single glance and see what's going on. So with a gauge, depending on where the needle is pointing, that gives the user a good indication to see exactly what's going on. And then the absolute number, that could be maybe on more of a detail or even a pop-up rather than on the gauge itself. And then again, limits. So you might have green for the needle in position is okay, and then you might have yellow limits for alarm, and then red for critical alarm. But again, too many colors can be confusing as well, so maybe you'd go with more muted colors like green and blue. Again, not so important what the colors are. You want to avoid too many colors, you want to avoid too much confusion, but you do need agreement. Another aspect possibly is also thinking about color blindness. So it's important that the colors contrast quite well, rather than what the actual colors are. But certainly with some men, green and sort of brown color blindness is common. Green and red can also be an issue. And then there are other levels of color blindness as well. So just check with your operators that they can actually see and work with the colors that you've chosen. So it would be nice within a single plant to really standardize and have consistent and common layouts and objects across the entire plant. Might not be possible because it might be you've got multiple generations of systems, you've got multiple different users, you've maybe got even different business units with different priorities, but it'd be really good to have standardization and consistency wherever possible. So common colors, standardization of navigation, even things like standardization of alarm messages as well, in terms of how the alarm message is presented, and simple things like the limits, high, low, high, high, low, low, and so on. Just make sure there is good consistency and everyone understands what there is. Again, training can help, and maybe also a user manual, and maybe even introductory videos as well to help the user. And possibly you could even include this aspect of training on the user interface itself, with maybe a mouse over, and when the user hovers, they get some sort of help guide and maybe an online tutorial or online help via a help button on the user interface as well. So I mentioned affordance. Affordance is the property of an object on screen to represent the real object in a way that humans can instinctively grasp. So for example, we've got the affordance of a floppy disk icon, which most users would know is the symbol for the save button. Even though floppy disks have been out of use for a long, long time, we immediately see a floppy disk icon. We know that if we click on that button, it's going to save our current progress. So that's an example of affordance. It can also mean a detailed representation of a machine component so that it looks like the real thing. So that might be an outline view. So for example, you see this a lot in automotive applications. When you're driving, you will see an outline or a logo that's representative of what it is we're doing. So for example, if you've got an engine problem in your car, there's probably an outline of an engine that goes red to indicate you've got a problem with the engine. Even in electric cars, I've seen that. The electric cars don't have a traditional engine, but that engine icon, again, that's that representation of that component, which is not completely exact, but very good in terms of its sort of icon. So ultimately, you might even go all the way up to a photo or photorealistic representation of the item in 2D or 3D to again help the operator understand what it is they're controlling, allow them to immediately understand the context and the control and the item, and again minimize the chance of mistakes. It's also important to have logical layout of items on the screen as well. So the flow or process of the operator and how it works is also important. So if you've got a plant, the flow of input to the plant through the processes to the right of the plant to the output, that might be a good way of having a logical layout of items on the screen, even if the physical plant doesn't look like that. Alternatively, you might want to go for a more physical representation starting with a top-down view. So again, depending how familiar your operators are with the plant, you might have a logical layout based on a plan view from above. I've even seen in some systems where people hire a helicopter, today you might use a drone, and they take an aerial view of the plant or process, and then they start overlaying real graphics on top of that photograph. Or you could use the photograph as a basis to build your photorealistic representation in sort of real scale of what there is. Of course, real scale can be problematic because there might be small but important parts, and there might be unimportant parts which are large. So you might also want to consider the logical layout rather than a precise physical representation. But that flow of the process can be very important to help affordance for the user. Again, be careful there because I mentioned left to right. That's how typical European languages work. But other languages, go right to left. So again, be careful of what your typical users would be, because what makes sense to one set of users might not make sense to another set. Something that I think is of less importance but often comes up in conversations is about screen response time. But this is important because again, this can result in operators who aren't happy with the solution, particularly if things take too long to happen. I think we're used now with websites where you click on a button and it can take a few seconds to load a new screen. We often see specifications where they ask for 2 seconds or less to change screens and 1 second or less for response time on the screen. So that there is an underlying aspect here, which is how fast do humans react. And typically, humans can react within half a second to 0.7 of a second. Faster than that is good. Faster than 0.7 of a second is perceived as adequate by a user, particularly if you're talking about pushing a button to seeing that button being depressed from, say, a touch action. Longer than 0.7 of a second is probably too long. That can result in user frustration, multiple button pushing, etc. So there is another aspect that we can detect flicker down to 0.1 second, but unless you've got something that's flashing on the screen, that's of less relevance for human-computer interaction in HMI SCADAs. But you do need that screen response, particularly to your user action. If something's going to take a longer time, then you might want to think about a progress bar. Another option is you might just want to show the operator that something has happened, even if then you're going to do something else that's going to take longer, but at least give them some sort of immediate update that at least acknowledges their action. So important one there, screen response time. Think of that magic number. It's about 0.7 of a second. Now, navigation can be important. Early systems used keyboards for navigation. I've even seen very old systems that use manual entry of a screen number, and the user had to either know what the screen number was, or they would have to have some sort of piece of paper telling them what the screen numbers were. Later, that could be achieved using function keys, which really just replace the screen number, and maybe arrow keys to move left and right and through screens. Of course, more recently, we've got access to mouse and trackball devices, or maybe use a touchscreen. And it's more common for a user to click or tap on a particular screen area, or maybe use navigation buttons in order to be able to navigate. And I think what makes sense to many people is a combination of navigation options. So you might have a navigation bar with buttons, maybe at the bottom or left of a screen. There might also be option to swipe using a keyboard swiping multi-gesture, and there might also be an option to click on an area of a screen or tap on an area of a screen and take you to that particular part of a plant. So don't think of navigation as being an either or. There are multiple options you can use for navigation, including potentially a triple tap on a screen where the user enters or selects that screen number or that screen name. So don't restrict yourself to a single navigation mode. Different users will appreciate different ways of doing it, and giving them multiple opportunities is relatively straightforward in modern HMI systems. So here's a typical navigation example for a HMI SCADA screen. This isn't prescriptive. This may not work for you. You may have your own ideas, but this is how I've often developed HMI SCADA screens in the past. So at the top, we have the title of the screen, and there may be control buttons there, for example, to log in or log out. Maybe there might be control buttons for having some sort of language switching or setup. So you can put those at the top. Again, the important thing is to be consistent. If you do it on one screen, do it on all of them. In the central screen area, we have the main visualization for the mimic or the control that the operator is concerned with. So this might be a picture of your tanks or vessels, or your picture of your machine, along with all the key performance indicators. And then what you can see here is we've got navigation being able to click on screen areas and move to different screens, or maybe by swiping. So typically those previous and next screen areas would be on the left or right of the screen. And then we may also have touch areas, so you can click on a pop-up and call up a pop-up for that particular item. It's often common to have an alarm banner on the screen that may be at the top, maybe under the screen title, or maybe where the screen title is, and then move the screen title elsewhere. In this case, we've also got a lower screen area which contains more menu buttons, so that just gives the operator multiple options for navigation. So you've got a predefined navigation area using buttons. Again, notice some common buttons for alarm and home. If you've got any common buttons like that, they should always be in the same place. Another nice idea is like a back button as well to go to the previous screen, but that will depend on what your HMI SCADA capabilities are. Not every HMI SCADA can just go back to the previous screen. And then there may be additional touch areas, so links to other screens, as we mentioned, maybe pop-ups to looking at the status of valves. And again, that's swiping for multi-touch navigation. And you can decide what your exact navigation might look like. But I think this is a nice, simple approach to adapt to whatever you're used to and to what makes sense for your application and your operators. Now, you could use the previous screen as your home screen with a picture of the plant that you then click on to get more information. Or you might want to start with a main menu screen. This is very common because it gives you a nice high-level view. And in this case, we can have screens that take you to each mimic area or cell or plant area or machine component. You can also have, again, those alarms and trends. This is also containing an exit button, so you can exit the application. But I would say today, we wouldn't normally do this. We would probably start with the previous screen, and the high-level screen would be an overview of the machine or plant, and we'd start at that level. So yeah, this main menu is a good idea, but we've already got some issues. The alarms and trend screens might be in different places. We've now got a completely different view. And this is almost pointless really for a real operator, because they're never going to view this screen except for once when they start up. Could be useful if you've got lots of different types of operators with different uses. You might want to point them to one screen to start with, and then they could go to their own hierarchy view. But often with modern HMI SCADAs, you can do that anyway, because if you can detect who the username is, you can give them a startup screen that's relevant to them. So you can have a home screen like this, but I'd say increasingly this is rare, and we'd normally start with a view starting like the previous screen, but with a high level overview, and it's rare to have a main menu. So here are some example layouts. You might have a common screen area here, so you've got the title or the alarm banner at the top of the screen, the main screen area in the middle, navigation bars at the bottom, and then you could put maybe your corporate logo top left along with configuration buttons at the top right. You could adapt that. Again, you might have a title or alarm banner at the top with configuration buttons, a main screen area, navigation along the left. I think the important thing about navigation is you just need to be careful about how much screen space it's using. Maybe it makes sense with widescreen displays because you've got more real estate now. But if you use up too much space for your navigation, then you're removing space for your main screen and for all of the aspects of actually controlling the plant. Pop-ups can give more information about an item. We call them pop-ups, but they could also be called overlay screens or faceplates. A pop-up could be a screen by itself. For plants with multiple items, you could have similar items and pop-ups, and they can reduce development time because you can implement a template solution and you can open the same screen multiple times with different data. So that's useful from a development point of view, but also that can enforce consistency, because if you use the same pop-up multiple times, then you've got the same layout, the same screen sort of design each time, even if it's for different elements. Faceplates extend the idea of a pop-up for control items, but they're very similar. But faceplates might include more specific data, for example, PID loops, where you might have the set point, auto manual, local remote control, and you might even include in there the PID tuning values, the P&ID values, and even maybe a trend to allow you to control and tune the PID loop. Both of those aid consistency and are well worth experimenting with and using. One thing you need to think about there is if you're using a pop-up or faceplate, think about the modality of control. If you have an option of a pop-up or a faceplate where it takes focus, then you might force the user just to have one pop-up or faceplate at a time, and they have to close that before they can go back to the main screen. But you might also have an arrangement where you could open multiple pop-ups and faceplates, but then you need to be careful that can your system cope with multiple faceplates or pop-ups? Will the operator get confused as to which has focus? And also you can end up with faceplates getting stuck. So you need to think carefully about how are you going to allow multiple pop-ups and faceplates to be displayed, or are you going to say I'm just going to have one pop-up and faceplate only? So again, modern graphic systems give you a lot more flexibility over how you operate that, but think about how that would impact on the way the operator interacts with the computer system. So here's the technical definition for pop-up and faceplate window types. Modal is preferred. With modal displays, the modal display appears on top of the main window, and this disables user interaction with anything that's behind the pop-up. The main window remains visible and continues to be animated, but the user can't click on anything behind the modal window, or if they do click, there will be no action. And what happens there is the modal window remains on top until it's closed. Ideally, there's only one modal window at a time, because if you have multiple modal windows, this could get very confusing because you could have pop-ups layered on top of pop-ups. That might work, but if the user gets lost or moves the windows, they might get confused as to which one is actually active and which one they can close to get to the previous one. Non-modal or modeless is another option. In this case, the new window still appears on top of the main window. The main window is still visible and active, but now you can continue to allow interaction and you can display multiple non-modal pop-ups. I've seen this system in quite a few applications where a limited number of non-modal pop-ups are allowed, for example, maybe 8 for process control. So what you can do is you can have 8 PID faceplates that are open. You can move those around on the screen. You can still see the main window, and then when you want to move, you either close them individually or close them one by one, and then that allows you to get back to the main window if you need it, or you could just navigate to a new window and they all close. That's a bit more difficult to manage from a system level point of view, but some systems do let you do that. But more concern for me would be, how does that impact on the operator? Are they capable of coping with multiple windows at the same time? Will they get confused? So I would normally go with that modal approach where when you open a pop-up, you have to close that pop-up before you can proceed with anything else. So how does all this impact on your development time? Well, my estimate for screen development time, it's always been pretty much 1 day per screen. Older systems maybe had more information, so it was easier to create just using boxes, simple screens, but you'd have more information. So it's typically 1 day for a lot of data. These days, I think even though the screens are less complex, you spend a bit more time making it look nicer and you've got less information there. So it's still really about 1 day per screen. Of course, there may also be some time to develop faceplates, standardization, standard objects, and so on. But that can actually help as well, because you might develop templates and layouts and library objects, which, although there's some setup time there, that then reduces your overall screen development time because you can use those objects. So I'd say in a typical system where you've got anywhere between 20 and 100 screens, I would normally estimate about 1 day per screen. On top of that, of course, you'd still have your project management time. There might be training time, there might be testing time, there might be time to develop documentation. But these days, even though the screen focus has changed, it's still typically 1 day per screen. And with modern graphic systems, if you're importing external images, maybe you're using photographs, maybe you can draw a more complex object, maybe on simple objects, but a good developer should still find that they can develop a reasonable screen regardless of complexity, and it's about 1 day per screen. So development time is unchanged, but you do need to think about those other aspects. Like I say, training can be important, maybe documentation, maybe adding more detail on the screens. Particularly if you get involvement of, say, a graphical developer, there may be something that's involved there. Graphic developers can certainly help with the affordance of the screens. But development time hasn't really changed in all those years. It's just the way the screens look is a lot better, and modern systems do help promote that. So quite a few aspects here for user interface and human-computer interaction. There's a lot more detail you can go into, but hopefully a few guidelines there that will help you and possibly guide your future research if you need to go into it in more detail.